What mass of iron 3 oxide and aluminum must be used to produce 15 grams of iron? What is the maximum mass of aluminum oxide that could be produced? Here I have the balanced chemical equation of this reaction, and I'm given 15 grams of iron, and I want to know what are the amounts of aluminum and iron 3 oxide that it would take to produce that 15 grams. And then the second question is, what is the maximum amount of aluminum oxide that would be produced? So let me begin by finding out how much mass of aluminum and iron 3 oxide would be required to produce 15 grams of iron. First thing I need to do is figure out how many moles 15 grams of iron is. After I figure out the number of moles, I can then figure out how many moles it would take of aluminum and iron 3 oxide to produce that 15 grams of iron. Then I can convert those moles into a mass by using the molar mass. And then I can go back and find out aluminum oxide. So first order of business, finding out the moles of iron. Grams of iron, and the molar mass is 55.85 grams per mole. This is going to give me 0.269 moles of iron. Now I need to do a mole-to-mole ratio to figure out how many moles it takes to produce of each of the reactants to get this 0.69 moles of iron. First, I'll do aluminum because that's the easiest one. It takes 2 moles of iron for every 2 moles of aluminum. So these cancel and I'm left with 0.269 moles of aluminum. That was fairly obvious. I did not need to even do this. But anyways, I did it. Now the next one, iron 3 oxide. This many moles of iron. Actually, I need a little bit more space. And for 2 moles of iron, it only takes 1 mole of iron 3 oxide to produce them. So when this is rounded up, this is 0.135 moles iron 3 oxide. Now that I have the moles of each of them, I can use the molar mass and convert to grams. 269 moles of aluminum. Molar mass of aluminum is 26, is it? 0.98? Yeah, but I'm stupid. Yeah. So these cancel, and this leaves me with 7.23 grams, I think. Times 26.98. No. 7.26 grams of aluminum. And now for iron 3 oxide, 0.135 moles. Iron 3 oxide. 1 mole is 159.67 grams, and this wound up being equal to 21.6 grams iron 3 oxide. These are the answers to the first part. It takes 7.26 grams of aluminum and 21.6 grams of iron 3 oxide to produce 15 grams of iron. Now the second part of the question is, what is the maximum mass of aluminum oxide that could be produced? And aluminum oxide is the second product of this reaction. So what I can do is just look at the moles of iron 3 oxide and then use that to calculate the amount of aluminum oxide, because they react 1 to 1. So I go back, I had 0.135 moles of aluminum 3 oxide. And they reacted 1 to 1. I could do a multi-role ratio, but I mean, I think it's pretty obvious that these are going to react 1 to 1. So I'm going to have 0.135 moles of iron 3 oxide, which means I'm going to get 0.135 moles of aluminum oxide product. And the molar mass of aluminum oxide is 101.93 grams for 1 mole, and this was equal to 13.8 grams.